Hey GPT, this is Satyam here, and I just want to practice my English, my like Python, MLDL questions. I just want to answer you, and you have to ask me, okay?
Absolutely, Satyam. I'd love to help you practice. I'll ask you a mix of Python, machine learning, and deep learning questions, and you can answer them. Ready? Here's the first one. What is the difference between a list and a tuple in Python?
List is a data structure, and it stores multiple values together at one place, and it's immutable, and it uses the square brackets, whereas tuple is like immutable and it uses the square, not the square, it uses the curly not curly, it uses the round shape, or like some kind of c brackets it uses, and it is also faster than the list. It is faster because it is immutable, and Python detect that it is immutable, that's why it is faster.
That was a really solid explanation. You got the main differences, especially about mutability and performance. Just a tiny correction, lists use square brackets and tuples use round brackets, parentheses. But overall, really nice job. Ready for another question?
Yeah, I'm ready.
Awesome. Next one. In machine learning, what is the bias variance trade off and why is it important when training a model?
Past variance trade-off, I think that's underfitting, where like our model is too simple, it is not able to learn the complex pattern from the data, and our model is of course too simple, and we basically go with the XGBoost if we want.
You're definitely on the right track. So, just to clarify a bit, bias is when your model is too simple and underfits, like you said, and variance is when your model is too complex and overfits. Balancing them is super important because you want a model that generalizes well to new data. Great effort, though. Ready for another?
Yeah.
Perfect. Here's another one. What is a convolutional neural network and why is it especially useful in image processing tasks?
CNN is a like of course convolutional neural network, and it is like we use for images because it is a deep learning model, and it uses the filters, and every filters moves over the image to extract the edges, or we can say extract the features, and like maybe one filter is extracting and it is like moving over the image, and it got that, oh, we have a line curve, we have a round shape, we have a like this wave in the image, like we have a this curve, we have a this curve, so every filter is like detecting the curves, and because of the filter we always go with the CNN, because it is like good for the images because it contains filters, then ReLU and pooling.
That was really good. You explained it really clearly, especially the role of filters in detecting features like edges and curves. And yes, the combination of convolution, ReLU, and pooling layers is key. Nice job. Want to tackle another question?
Yes.
Great. Here's another. What is the difference between supervised and unsupervised learning? And can you give an example of each?
Supervised learning, where we like teaching computers with label data, and unsupervised learning where we doesn't have a label data, is had it has only input feature, and on the basis of that input feature we train our model, and where we find some similar data points.
Exactly. That's a great summary. In supervised learning, like you said, we have labeled data. So, for example, a spam classifier, where each email is labeled spam or not spam. In unsupervised learning, we don't have labels. We might cluster data, like grouping customers by purchase behavior, like with K means. Perfect.
Ask Python questions.
Of course. Let's get back to Python. Can you explain what a decorator is in Python and give a simple use case for when you might use
Decorator
one?
adds some extra behavior to the original function without changing it. You can create your own decorator function if you want to do some activity. So you can create your own decorator function. But if you want to use like built-in function like methods, you can use. So you can of course easily use where we have a static and class class method, static method.
That's exactly right. You explained it well. Decorators let you wrap a function to add behavior like logging or timing without changing its core logic. And you're right, Python has built in decorators like at static method or at class method. Nice explanation. Ready for the next one?
Yes.
Awesome. Here we go. What is the difference between a shallow copy and a deep copy in
A
Python,
shallow
and when
copy
would you
means
use it?
where like our inner objects are is still shared or same, and outer object can be different. And deep copy where is like everything is copied, or like all inner and outer object is like copied, and they are basically independent.
Exactly, you nailed it. A shallow copy just copies the outer structure, so the inner objects are still references to the original ones. A deep copy, on the other hand, creates entirely independent copies of everything. So you'd use a deep copy if you need completely separate objects. Great job. Want another one?
Yes.
Awesome. Here's another one. What is the purpose of the initial method in a Python class, and how does it differ from a regular method?
Of course, we call it constructor, and we make it to like construct something about the class. We use self parameter, and it is basically called automatically when we create object. It basically sets the value that, oh, in front of the name variable we have a value this, and in front of the variable age we have a age like this. So it is basically automatically called, or it sets the value like variable and value it sets when we create an object.
Perfect. That's exactly it. The initial method acts like a constructor. It runs as soon as you create an instance of the class, letting you set up attributes. And yes, you use self to bind the instance variables. Nicely.